Hello all. Today we are going to discuss about remote interfaces and implementation. First, remote interface. It is also called as a client interface. A remote interface provides the description of all the methods of particular remote object. The client communicates with this remote interface. First, to create the remote interface, first step, create an interface that extends the predefined interface remote which belongs to the packet. Second one, declare all the business methods that can be invoked by the client in this interface. Since there is chance of network issues during the remote call, an exception named remote exception may occur through it. Following is an example of a remote interface. Here we have defined the interface with the name hello and it has a method called print message. Let us consider the program. Import java.rmi.remote, import java.rmi.remote exception. First, creating the remote interface for our application, public interface hello, extend remote, void print message through remote exception. In this way, we can created and remote interface. Then next topic is developing the implementation class, that is remote object. We need to implement the remote interface created in the earlier step. We can write the implementation class separately or we can directly make the server program implement this interface. To develop an implementation class, first implement the interface created in the previous step. Second, provide the implementation all the abstract method of the remote interface. Following is an implementation class. Here we have created a class named IMPL impl example and implemented the interface hello created in the previous step and provided body for this method which prints a message. First, implementing the remote interface, public class impl example implements hello, then implementing the interface method public void print message system.out.println. This is an example RMI program, curly bracket complete. In this way we can developing the implementation class or we can creating the implementation class for remote interface. Then next one is server interface. In server interface, first the reference interface. The java.rmi server is a server for the java.rmi. The unreference interface allows a server object to be noticed that no client have a remote reference to it. The RMI runtime preserves a local reference to the remote object as a remote reference to it. The unreference interface does not need to use the remote object. The distributed garbage collection system keeps the track of the number of a client virtual machines that have a reference to a remote object for each remote object. The RMI runtime preserves a local reference to the remote object as long as some client have a remote reference to it. Let us consider the example for the server interface. Import java.rmi server in public interface unreference public void unreference. The unreference method is called once the remote object's reference set become empty. That is, when the number of clients who reference the object becomes 0 if that remote object implement the unreference interface. The unreference interface does not need the use of the remote object. It may be passed to remote call or return to clients as long as local reference to the distance object exists. The reference is added to the distant object reference set by the process that receive it. The remote object unreference method will be called when the reference set becomes empty. As a result, the unreference method can be used several times. Each time is set the newly empty. Remote objects are only collected when there are no more references, either local or a client-held references. Then second one is the loader handler interface. The loader handler is an interface used internally by the RMI runtime in the previous implementation version. It should never be retrieved by application code. The loader handler interface was only used by the JDK 1.1 internal RMI implementation. The loader handler interface is criticized in the Java 2 platform. Let us consider the example for that is program import java.rms server public interface loader handler class load class string name curly bracket companies throw malform URL exception class not found exception class load class URL code base dot string name throws malform URL exception class not found exception object get security context class loader. This is the program for the loader handler interface. Then third one is the RMI failure handler interface. The RMI failure handler interface allow you to specify how the RMI runtime should react if the server socket construction fail, except during the object export. The exception that stops the RMI runtime from generating a java.net.server socket is passed to the failure function. Let us consider the example for that. Package or import java.rmi.server public interface RMI failure handler public boolean failure in bracket exception dot example. If the runtime should try again, the method return true, otherwise it return false. A failure handler must first be registered using the RMI socket factory dot set failure handler. Call before this method can be used. If the failure handler is not specified, the RMI runtime attempts to recreate the server socket after a brief delay. When the server socket creation fails during the initial export of the object, the RMI failure handler is not called. When an attempt to construct a server socket fails, the RMI failure handler is called. This is all about the RMI failure handler interface. Next is the registry interface. The java.rmi.registry interface and the java.rmi.registry are used by the RMI system. A registry is the remote object that serves as a name to remote object mapping. To provide the well-known Bootstrap service for retrieving and registering objects by simple names, use the local registry class. A single registry can be used for a host or any server process can support its own registry. Local registry methods are used to get a registry running on a specific host or a host and port. The java.rmi naming classes method use the proper local registry to contact a remote object that implement the registry interface. The get registry method is used to retrieve information about the registry. The java.rmi.registry method registry.registry remote interface provide lookup, binding, rebinding, unbinding and listing method for a registry content. The registry remote interface is used by the java.rmi.naming class to enable URL based naming. Let us consider the example program package java.rmi registry public interface registry extend java.rmi remote public static final int registry port is equal to 1099 public java.rmi.remote lookup string name. This program represents how we can use the registry interface. Then next, in this way we can use the registry interface. The registry port is the registry's default port. The remote object bound to the supplied name is returned by the lookup method. A set of remote interfaces is implemented by the remote object. The remote object can be cast to the expected remote interface by a client. This cast may fail in the same manner that other cast in the Java language may fail. The name is associated with the remote object using the bind method. The already bound exception is thrown if the name is already linked to an object. The name is associated with the remote object using the rebind method. Any prior name binding are discarded. Unbinding are the name from the remote in object. Is the done with the unbind method. The not bound exception is triggered if the name is not already bound to an object. The list method returns an array of a string that contain a snapshot of a registry name. The return value is snapshot of the registry content. The next type of interface is the registry handler interface. The interface registry handler is used to interface to provide the implementation. Let us consider the example for that program package java.rmi registry, public interface registry handler, registry stub, string host import, throws java.rmi.remote exception, java.rmi unknown host exception, registry import, throws java.rmi remote exception. This is an example or a program that represents the registry handler interface. The registry stub method returns a stub that may be used to contact a remote registry on the supplied host and port. The registry impl method create and export a registry on the given port. The port must be greater than 0. The client can use the local registry and registry interfaces as well as the methods of the URL based java.rmi.naming class to access the registry. Only client on the same host as the server can bind, unbind and rebind. However, any host can perform a lookup. Then next type of RMI interfaces is stub skeleton interfaces, in which first one is remote call interface. The interface remote call is an abstraction used by the stub skeleton of the remote object to carry out the call to the remote object. The get outstream method returns the outstream into which the skeleton marshal result or the stub marshal arguments. Output stream releases the output stream. This will release the stream in a sum transport. The get input stream method returns the input stream from which the skeleton unmarshals parameter or the stub unmarshal results are obtained. The input stream is released when the input stream is called. The get result stream method returns the stream of output after writing out header information relating to the success of the call. Per remote call, only one attempt at obtaining a result stream should be successful. The result to be marshaled is a standard return if the success is true, otherwise the result is an exception. The stream corrupted exception is thrown if the result stream has already been obtained for this remote call. The method execute call does whatever it takes to execute the call. The method done allow cleanup after the remote call has completed. Let us consider the example for the remote call interface is program package java.rmi.server import java.io public interface remote call object output gets output stream throws IO exception void release output stream throw IO exception output object input get input stream throws IO exception void release input stream throws IO exception object output gets result stream boolean success throws IO exception stream corrupted exception void execute call throws exception void done throws IO exception. This program represents how we can use the remote call interface. Then next one is the remote ref interface. The interface remote ref represent the handler for a remote object is represented by remote ref. Each stub has a remote ref instance which holds the concrete representation of a reference. This remote reference is used to make a remote calls to the remove object it is a reference to. The invoke remote method or object log method delegate a method invocation to the stub's remote reference, which is responsible for establishing a connection to the remote host, marshalling some representation for a method parameters and communicating the method invocation to the remote host. If the call fails or if the remote invocation throws an exception, this method either returns the result of the method invocation on the remote object that lives on the remote host or throws a remote exception or an application level exception. It's worth noticing that the operation number of num is a hash of the method signature that can be used to encrypt the method for a transmission. Let us consider the example for that. The program package java.rms server public interface remote ref extend java.io externalization remote call new call remote object operation of int of num log hash throws remote exception void invoke remote call throws exception void done remote call throws remote exception string get ref java.io object output out int remote hash code, boolean remote equals remote ref object, string remote to string. This is a program is used for the remote ref interface. Then next one is the server ref interface. The interface server ref represent the server side handle for the remote object implementation. The method export object finds or created a client stuff object for the supplied remote object implementation object. The parameter data contain the necessary information to export the object such as port number. The get client host method return the current client host name. When called from the thread actively handling a remote method invocation, the host name of the client invoking the call is written. If the remote method call is not currently being serviced, then server not active exception is called. Server not active exception is thrown if the remote method call is not present being survived. Let us consider the example program for that. Server ref interface is package java.rmi server public interface server ref extend remote ref remote stub export object java.rmi remote object data throws java.rmi remote exception string get client host throws server not active exception. This is a program or the example for a server ref interface. Then next type of interface is the skeleton interface. The interface skeleton is used solely by the implementation of the skeletons generated by the RMIC compiler. A skeleton for the remote object is a server-side entity that dispatches call to the actual remote object implementation. The dispatch method unmarshals any arguments from the input stream obtained from the call object, invokes the method indicated by the operation number opnum. On the actual remote object implementation ops and the marshals the return value or the throws an exception if one occur during the invocation. The get operations method return an array containing the operation descriptor for the remote objects method. Let us consider the example program for the skeleton interface. Package java.rmi server public interface skeleton void dispatch remote ops remote call int opnum long hash throws exception operation get operation. This is a program that represents how we can use the skeleton interface. Thank you guys.